That's why I'm just gonna wait till it comes out with the grade tomorrow and be like,
Alright. Good afternoon.
Yeah, where is it?
So there are two topics left that I'm going to cover for this course.
Charlie, you're in the way.
The first one is past generation.
Yeah, where is it? Does Adam sound like a class? Okay, she wouldn't be surprised.
he was at the receiving something.
Does?
Yeah.
So do you think Adam is what is that?
Yeah, no one was gonna draw it. Not gonna teach it.
So we are gonna
One class.
synthesis a four-bar mechanism to provide desired path. And the past generation that we're covering is prescribed timing. We talked about that at the beginning of synthesis chapter, but I'm gonna talk about that again. So past generation, suppose point P is at coordinate x1 and y1. You would like to move point P from this position to this position, x2, y2, and then x3, y3. So we are given with three precision points: point P at first precision point, point P at the second precision point, and point P at its third desired location. And you would like to come out with the design of a four-bar mechanism such that is moving point P through these three precision points. So there is a difference between past generation without prescribed timing and past generation with prescribed timing. Suppose this is the four-bar mechanism that we are going to design, and this link is a ternary, and point P is somewhere here. This is the input angle, theta. If you would like to have this mechanism at this position, but you don't mind what would be the input angle when this mechanism is at this position, we have for past generation without prescribed timing. But if it's important for you, the input angle when point P is at first precision point, at second precision point, and third precision point, then we are saying that we have past generation with prescribed timing. What I say is, if you would like point P is at x1, y1, and theta 1 is important for you, so you would like to have it at 20 degrees, then theta 2 is 60 degrees, point P should be at second precision point, and when theta 2 at 84 degrees, you would like P be at third precision point. If this is the case, we call it past generation with prescribed time. So the timing is important for you. So in this chapter, in this lecture, we are gonna go over past generation with prescribed timing. Suppose suppose input link, which is this, rotates at 1 RPM, 1 revolution per minute. Every 60 seconds, the input link is going to complete 360 degrees. And point P is at 9 and 3. First precision point for point 3 is 9 for X and 3 for Y. 15 seconds later, point P is at 6.4. 15 seconds later, after 15 seconds, point P is going to move from first precision point to the second precision point. I gave you the speed of the input link. It's a 1 revolution per minute, meaning omega is 360 degrees per minute or 6 degrees per second. Every second, this input link is going to move by 6 degrees. 6 degrees times 15 seconds, 6 times 15 is going to be 90 degrees. So when you are moving from first precision point to the second precision point, the input link is going to cover 90 degrees. It means theta 2 minus theta 1, which is theta 1, 2, is 90 degrees. So this timing is important. You would like point P 15 seconds later be at 6.4. And 5 seconds later, point P is at 8.1. So 5 seconds here, 15 seconds there, 20 seconds from the starting position. 20 seconds times 6 degrees is going to be 120 degrees. It's going to be theta 3 minus theta 1, or theta 3, 1. So if I want to write it down here, theta 1, 2 should be 90 degrees, theta 1, 3 should be 120 degrees, when P1 is 9 and 3, P2 is 6 and 4, and P3 is 8.1. So we would like to design a forward mechanism such that it generates this desired path. Good? So if I didn't give you this, I just wanted to design a forward mechanism such that it goes over these 3 points. We just had path generation without prescribing. All right, it's similar to motion generation. So we would like to design this forward mechanism such that it's moving through this 3 precision point. What we are going to do, we define vector V1, vector V2, and vector V3 to reach point P. And from the other side, I'm going to go V4, V5, V6. I divide it to 2 diodes, left-hand side diode and right-hand side diode. Left-hand side diode is going to be V1, V2, V3. Right-hand side is going to be V4, V5, V6. First, I'm going to look at the right-hand side. In right hand side, if I want to reach point P, I can say vector OP is going to be V1 plus V2 plus V3. If I add them up, I will reach point P. This is V1, V2, V3. Point P is at first precision point. When the input link is moving to the second precision point, this link is going to move to the second precision point. If I draw a line at this point, parallel to this, the angle between these two lines would be gamma 1, 2. This is the gamma 1. If I draw a line here, parallel to the ground, this angle would be gamma 2. The difference between these two is going to be gamma 1. And similarly, this angle would be gamma 1, 2. So for the first precision point, I can write the x component of point P, which is x1, is going to be a cosine of alpha plus b cosine of theta 1 plus c cosine of gamma 1. And y of point P would be y1 equals to a cosine of alpha plus b sine. C sine of gamma 1. This is first precision point. Second is going to be x of P. It's going to be at x2. Y of P would be at y2. A and alpha is not, they are not changing, but theta 1 is going to be at theta 2. You can do it for the third precision point as well, right? Have these two equations for first precision point, second, and the third. Totally, you are going to get 6 equations. Now we are writing all angles with respect to first precision point. So if I have theta 2, I replace it with theta 1 plus theta 1. If I have gamma 2, I'm going to replace it with gamma 1 plus gamma 1. If I have theta 3, I'm going to replace it with theta 1 plus theta 1, 3, and gamma 1 plus gamma 1, 3. I'm going to rewrite the equation in this form, and then I expand them, same as, it's similar to the motion generation. If I expand this, you know how to expand the cosine and sine term. Then I define some intermediate variable. A cosine of alpha is P, A sine of alpha is Q, B cosine of theta 1 is R, S, T, and U. So first equation is going to be P plus R plus T equals to x1. x1 is the coordinates that we would like to have point P at first position. Q plus S plus T, plus U would be y1. If I expand this, I'm going to get this as a 6 equation. It's a I summarize them in this notation. It's going to be easier to represent all 6 equations. But if you like, you can expand them and have all 6 equations. Anyway, we are going to have the unknowns will be P, Q, R, S, T, and U. In motion generation, we end up to the same equation because right now they are the same. In motion generation, when I had this one, the unknowns were P, Q, R, S, T, U plus T1, 2, theta 1, 2, and theta 1, 3. And we picked 3 choices as a theta 1, 2, and theta 1, 3. But in past generation, theta 1, 2, and theta 1, 3 are given. It was 90 and 120 degree in this example. But gamma 1, 2, and gamma 1, 3 are unknowns. Here, gamma 1, 3 and gamma 1, 2 are known because we are given with the coordinates of a point plus the rotation of the line of the region, gamma 1 and gamma 1, 3, they're known. But here, gamma 1, 2 and gamma 1, 3 are unknown. So this is the only difference between these two. So free choices would be this. Gamma 1, 2 and gamma 1, 3, you pick 2 values for them and solve for P, Q, R, S, T, and U. After you find P and Q, you can find A. A would be S square root of P square plus Q square. What will be the alpha? Alpha would be cosine of alpha is going to be x1 divided by A would be cosine of alpha, and y1 divided by A would be sine of alpha. From here you will get 2 angles. For the second one you get 2 angles, find the matching pair. Alpha and A can be calculated. B would be R square plus S square. And theta 1 would be this is P and A. This is gonna be R divided by B would be cosine of theta 1, and S divided by B would be sine of theta 1. You solve for theta 1. And similarly, you can find gamma 1. So, for the left-hand side, we have alpha, we have A. We can find the location of joint O2. Second thing, you have theta 1. You have B. You can find point A. And gamma 1 and C. You can find point B. Now we are gonna look at the right hand side diagram. B4, B5, B6. Same as OP would be the same. B1 is gonna change to B4. B2 is gonna change to B5, and B3 is gonna change to B6. Now X1 is gonna be the same. A is gonna change to B, cosine of beta, B is gonna change to E cosine of phi 1, and C is gonna change to F, and the gamma 1 is gonna change to psi. P prime, Q prime, R prime, S prime, T prime, and U prime. So D cosine of beta, E cosine of phi, F cosine of eta equals to x1. Similarly for y1. For all 6 equations, for all 3 decision points, I'm going to use I instead of repeat this equation for the second and the third. And then I'm going to write all angles with respect to the first precision point. This equation is going to change to this. I replace phi by phi1 plus phi1 and eta y with eta 1 plus eta 1. So in this equation, the unknown will be P prime, Q prime, R prime, S prime, T prime, U prime. What else? Now theta V12, V12, V13. Eta 12, eta 13. We got 10 unknowns, but same as motion generation, eta 12 is gonna be equals to eta is gonna be the angle of this link with the ground, and this line has the angle of lambda with the ground, but whatever is the rotation of this line is, it's going to be the same for this line. So eta 12 is gamma 12. So whatever you pick for free choice for the left hand side diode, you should pick the same thing for the eta 1, and eta 13 would be gamma 12. So free choices would be phi12 and phi13. So we solve for P prime, Q prime, R prime, S prime, T prime, and U prime. Then we can find D and beta, E and P1, F and eta 1. So if I ask you to draw or sketch the mechanism, you should first sketch the left and then right hand side of the diode, and you are going to get the complete mechanism. And the mechanism is going to move point P from the first precision point to the second. And yes?
What changes when we have to move not a point but a rigid point? Like on the where we have to move a line?
It's a last topic that we are going to cover. Next one. Any question on this? Alright. So sometimes you are given with motion generation of mechanism, of a rigid body, but instead of having a coordinates of a point and orientation of the rigid body, we are given with the location of 2 points on the rigid body. Suppose this is the rigid body that we have, rigid body AB. Point A and B, you know the coordinates of point A and B. These are the points of joints. So the joints is going to be at, one of the joints is going to be at A1, the other one would be at B1. So 4 joints would be OA, A1, B1, and OB. Now, this rigid body, you have the coordinates of these 2 joints. You are given with them. So you would like to move this plane, these 2 joints, from this position to this position and this position. So how can we find the location of ground joint? So x A1, y A1 is the coordinates of joint A at the first precision point. First. X B1, y B1 is the coordinates of joint B at the first precision point. Second is going to be x A2, y A2, and x B2, y B2. Third, x A3, y A3, x B3, y B3. So the goal is finding the coordinates of joint OA and joint OB, meaning XO, YO, and X prime O, Y prime O. So we are looking for this coordinate and this coordinate. So totally we have 4 unknowns, 2 for coordinates of this and 2 for coordinates of the second. So the approach is simple. If I connect OA to A1, it's going to give me link 2. Link 1 is ground, link 2 is OA A1. When this mechanism is moving from first precision point to the second precision point, OA A1 is going to move to OA A2. And to the third precision point, OA A1 is going to move to OA A3. Saying that, I can say OA A1, the length, is going to be OA A2, is going to be OA A3. Make sense? So now, what is the OA A1? For the distance between 2 points. Point 1 has this coordinate and OA has this coordinate. It's gonna be OA A1. It's gonna be X A1 minus XO square plus Y A1 minus YO square root. This is gonna be OA A1. So this must be equals to OAA2 with this one. Just OA2 minus X A2 minus XO square plus Y A2 minus YO square. OA2, the distance between these 2 points is going to be X component of this or this minus the other one square plus Y component of this minus the Y component the other one square. So also I can say this must be equal to this one. So keep this here again. x a3 or a3, x a3 minus x o squared plus y a3 minus y o squared. Any question on this? I just said this equals to this is the equation, and this equals to this. This is the equation. Two equations. Unknowns would be xo and yo. So what I can do, I can square both sides, get rid of this square root. So I'm gonna get this equation xa1 minus xo squared, ya1 minus yo squared equals to xa2 minus xo squared plus ya2 minus yo squared. And this equation is going to be the second equation that I have. What I need to expand them. X a1 squared plus xo squared minus 2x a1 xo plus y squared of a1 plus y squared of o minus 2y a1 by o equals to the right hand side square, which is this. So I can cancel out these 2x squared from both sides, this yo squared from both sides. What I left is xo, xo, yo, yo. So if I simplify the first equation and move the unknowns to the one side, which is xo term and yo term, I'm going to get this equation. Move the knowns term to the other side, which are these terms. It's going to be here. Then for this equation, do the same things. What I need to do, only change a2 to a3, a2 to a3, a2 to a3, a2 to a2. And the rest will be the same. So two equations to unknowns in MATLAB or by solving this system equation. Solve for xo and yo. Homework, problem 4 of the homework is asking me to do this. Now we find the coordinates of this joint. We are done with this joint. We just need to repeat the same approach with joint OB. But instead of having OA A1, I'm going to have OB B1. OB B1 equals to OB B2 equals to OB B3. So XA1 is going to change to XB1. XB1 minus XO is going to change to X prime O. That's good. Plus YB1 minus Y prime O square equals to YB2 minus Y prime O square plus YB2 minus Y prime O square. And second equation, xb1 minus x prime O square, same thing. Just repeat this. And xb3 minus x prime O square plus y prime h3 minus not y prime O square. So this equation and this equation solve for x prime O and y prime. So then you can find the coordinates of this joint and we are done. Good? Yes.
Is that y b2 via x b2? On the second equation down, on the right hand side.
This one?
No.
Or this one?
Yeah, on the other side.
Yes, thanks for catching. And the second system of equation is going to look like this. Same as this first set of equation, except here we are going to change a to b and x o and y o to x prime o and y prime o. So we have two equations for now. We are going to get the coordinates of joint B. And that's all. We are done with this course. You did very well. It's more than 3 credit course, I agree. You have done a lot of coding, a lot of homeworks, public exams, so you should be proud of yourself. So exam. Exam would be on Science Center, the same room that we had exam 1 and 2. On Wednesday, 1:15 to 3:15. There are most likely 4 problems. 2 of them would be from kinematic synthesis, what we covered after the second exam. And the other 2 would be from displacement, velocity, whatever we covered for the first 2 exams. You are allowed to bring 3 sheets, both sided, whatever you want to have. 6 pages total. You don't need to have, but you can. Yes, 3 pages, both sided. 6 pages.
We did the process to build something that we But we built it with wood.
How are we getting our test back?
Yeah,
Yeah, I feel like
You didn't add the motor to that. You should add it.
electrical motor.
It's gonna be cool.
Is that a requirement or not?
Yes, for these projects, yes. Because it's not difficult.
Yeah.
Why not? I mean, you just need to
Yes, because it's like nothing. Like it's just a bunch of random equations. There's like a million of them. Yeah.
That's all this is applied to. That's literally what this degree is.
As long as you can process right, that's all. It doesn't care if you it's like a super.
I also have
the final product first. Then I'm done with the file and the video. No, you should just stop by my office, bring, for your project, the due date is gonna be on Thursday, one day. I had it one more day after the exam. December 12. December 12.
Are we gonna get our test 2 back?
Yes. I left it at home.
Okay.
We don't have class tomorrow, but I'll bring them. You can stop by my office. And for the project, what I need is the final product, and you should bring a flash drive with the I mean, the video that you have recorded plus the SolidWorks file. I'm gonna download the files on my desktop and give it back to you. Flash drive.
Use our time taking bonus exams.
And find out more.
Alex, can you just send
We should do the course evaluation. I need a volunteer to collect them and give it to
everything? Send me
Laura.
everything in the email, every individual part. I want to see everything. Okay.
Yes.
Thank you. Yes, yes, yes.
Yes. Yeah. I'm gonna send him that. The homework due is gonna be Monday. The due date for the homework next Monday.
You're welcome. You're welcome.
Another question. What if we
I got
just
it.
put order
Don't
in
worry, I got
the
you.
system?
I know. I'm on top of it. Everyone.
Okay, you don't mind if
Everyone,
it's
okay.
me, no?
Don't
I
worry.
have a
Don't
project
worry.
made of the wood,
Okay.
and they added the electricity to that.
I
Not
have
this one, but
project.
this one.
Okay. We can increase the price, but I don't think.
Did you talk to
Okay.
them? I know that they line up.
Yeah,
How long
yeah.
is that take? From today you are gonna take it. So each day I think we can print out 2-3 projects, depending on the, I know that. But some projects are big, some projects are small.
We'll talk to him, but like the worst thing, we can just attach him over anyway.
Whatever works. Yes.
Anytime today.
So I'll be available in my office tomorrow. It's 9:30 to afternoon, yes. And today I'll go to my office. I have a class at 1.
I'll probably meet you tomorrow. Very questions about the project.
Sure.
If I can't figure out the transmission, I'll put it in.
Okay, bring it tomorrow.
Oh, wait, no, they don't say it.
Or on back.
Oh, by you. I have fun. We need something to
I forgot to bring, I
something online, right?
I'll look at it now. Yes, I can. The pencil, if you need.
I think
Everybody has a pencil.
He knows it's there. He knows it's there.
Or you won't believe this.